The last thing I want to show you as far as solids of revolution is taking a look at page 641. And here we're going to take a shape and we're going to spin it around the y-axis instead of the x-axis. And we're going to see how that changes the formula around a little bit. So once again, we're taking this shape. It's a parabola and it's a straight line. It's really exactly the same problem as we had in the last problem, except kind of tilted on its side. But in order to solve this, what we're going to do is we're going to basically imagine what's our rectangle that we're rotating. And so this time, the rectangle that we're spinning around the y-axis looks something like this. All right, and we're spinning it around this way. Okay, so once again, we're going to think about our volume 1 and our volume 2. But we've got to think a little bit differently about what our bounds of integration are and what we're going to be integrating. So before, we were thinking about the left and right-hand sides of the integration. This time, we're going to think about the y values of the top and bottom. And so this is going down as far as -1, and it's going up as far as +2. So this is going to be -1 and +2. And now we've got to think about how long is this rectangle? Okay, and so it's going to be some value of x in terms of y. I'm going to say, okay, so it's this high up. This is my y value. I want to know what x value goes along with that. So what I need to do is I need to think about this line. Y is equal to plus or minus the square root of x. And I need to solve this so that I can get values of x in terms of y. Okay, so how can I solve this for x? Well, the first thing I'm going to want to do is I'm going to want to square both sides of the equation. So y becomes y squared. The plus or minus is going to go away because if I'm multiplying two positives or two negatives, it's just going to wind up as a positive. And the square root of x times the square root of x is just x. All right, so they were describing this line as y is equal to plus or minus the square root of x, but we could just as easily think of it as y squared equals x. And we're going to think about the same thing for this line. So this line is y equals x minus 2. But if I want to solve this for x in terms of y, how do I get the x by itself? Well, I'm going to add 2 to both sides of the equation, and that's going to give me x equals y plus 2. Okay, and so that's going to give me an idea for the length of this rectangle. So the length of this rectangle is going to be y plus 2. I should put the pi outside here because we always do that. Y plus 2. And I need to square that because that's what we do to find the volume of a cylinder. And then the width of this cylinder is going to be a small value of y. So that's dy. And same thing for the inside shape. It's going to be this value of the parabola. And so that's pi times that function is y squared dy. So this is really exactly the same problem as we had for our first problem on the previous page. It's just twisted 90 degrees. So this is the kind of thinking you need to do if you're rotating something around the y-axis. It's just a matter of solving the equations for x instead of y, and then using those to represent the radius of your cylinders, and then dy is representing the length. And then you're just going to find those definite integrals just like you did before, and then subtract them to find the area of the volume of the total shape that you come up with. The other two problems were exactly the same thing, just talking about different vertical lines than the y-axis. And you're going to solve that in exactly the same way we did in the previous videos. All right, so that's all you need to know about volumes of revolution in order to answer the kind of questions that they'll toss at you in the Regents exam. I'm sorry, the AP exam. And so we have now taught everything that you need to know to make it through AP Calculus. So good job. From here, we'll be working on review for the rest of the year leading up to the test itself.